Welcome to Science to Sleep By. Tonight, we drift beyond the glittering spirals of galaxies, beyond the starlight, beyond the nebulae into the quiet, into the space between. It is not empty, it is not nothing, it is the breath between cosmic heartbeats, the stillness between the songs of the stars. I invite you to close your eyes and travel with me into the intergalactic deep to discover what truly lies between galaxies in our universe, far beyond the luminous spirals and elliptical clusters of the galaxies that populate our universe. There stretches an expanse so vast, so still, that it challenges every human sense of space and distance. Between the galaxies, beyond the dense neighborhoods of stars and gas, lies a realm that seems almost untouched, an intergalactic wilderness, silent and slow. It is here, in these immense gulfs of darkness, that the true scale of the cosmos is revealed. When we look up at the night sky from Earth, we are seeing light that has traveled unimaginable distances, light from galaxies that sit like tiny islands in a cosmic ocean. But between those islands is the ocean itself, the seemingly empty and seen vastness that makes up most of the universe's volume. This is the domain we are entering tonight, the silent expanse between galaxies. The human imagination often tries to fill this space with something tangible, because true emptiness is hard to comprehend. We are used to the fullness of things, air, water, the hum of life all around us. Even in the quietest moments on Earth, there is a sense of presence. Yet intergalactic space defies that instinct. It is a place where there are no winds, no atmosphere, no sound. The distances are so extreme that even light takes millions of years to cross from one galaxy to another. The nearest large galaxy to our own, Andromeda, is about 2.5 million light-years away, meaning the light we see from it tonight began its journey before humans existed as a species. Between us and Andromeda lies a gulf so wide that entire clusters of galaxies could fit within it. Yet, in that vastness, there is almost nothing that our eyes could ever see. But the word nothing is deceptive. Space, even intergalactic space, is never truly empty. It is filled with the faint whispers of existence, atoms drifting alone, particles that rarely meet, and ancient radiation that has been traveling since the birth of the universe. When scientists measure the density of matter between galaxies, they find only a few hydrogen atoms per cubic meter. To put that into perspective, a single breath of air on Earth contains around 10 quintillion molecules. Compared to the richness of our world, the spaces between galaxies are unimaginably thin. Yet, on the cosmic scale, this faint matter is enough to shape the structure of the universe itself. If you could drift there, in the deep void between galaxies, it would not feel like floating in darkness. It would feel like falling into eternity. The starlight would fade until only a few glimmers remain, points of light so distant they appear frozen in time. Around you, the silence would be absolute, not because it is quiet, but because there is nothing to carry sound. The temperature would hover near absolute zero, a few degrees above it, where atoms move slower than any motion we can perceive. In that stillness, you would feel the true weight of distance, not as something to cross, but as something that simply is. The galaxies, for all their brilliance, are small compared to the cosmic space that surrounds them. Our own Milky Way is about 100,000 light-years wide, yet the distance to our nearest galactic neighbor is more than 20 times that. Between them lie regions so dark that no telescope sees them directly. What astronomers do detect, however, are faint signatures of gas, the ghostly glow of X-rays, and the invisible tug of gravity from dark matter that holds galaxies together like beads on a thread. That invisible thread forms part of what scientists call the cosmic web, an enormous network of filaments and voids that spans the universe. Even in the vast emptiness, there is structure, subtle, graceful, and ancient. When cosmologists model the universe, they find that most of its volume consists not of galaxies, but of these empty spaces between them. Galaxies are the punctuation marks in an immense cosmic story, while the intergalactic voids are the spaces between the words silent, but essential. It is there that the light of ancient stars continues its endless journey, that the relic radiation of the Big Bang still hums faintly, and that gravity quietly shapes the architecture of all things. The spaces between galaxies are not places of nothingness. They are the canvas upon which the universe paints its story. Imagine for a moment that you could leave the Milky Way. You rise above its luminous disk, past the clusters of stars, past the halo of dark matter, past the last few drifting globular clusters that orbit our galactic home. Soon, the Milky Way becomes a soft spiral of light behind you. The stars are no longer distinct. They blur together into a pale, glowing swirl. Ahead lies blackness, an ocean without horizon. You travel for thousands of light years, and still encounter only a handful of atoms in every cubic meter. You pass through invisible clouds of gas that stretch for millions of light years, their presence detectable only through the faint absorption of distant starlight. There are no boundaries, no up or down, just distance infinite, patient, and still. In this place, the scale of the cosmos becomes humbling. Everything human, our thoughts, our memories, our histories, feels like a fleeting spark. And yet, that spark comes from the same matter, the same energy, that drifts silently between galaxies. The hydrogen that fills those spaces is the oldest element in existence, formed just minutes after the Big Bang. Over billions of years, some of that hydrogen gathered into galaxies, into stars, into planets, and eventually, into us. The rest remains adrift, waiting, part of the great balance of the universe. When you imagine the space between galaxies, you are not imagining isolation. You are imagining continuity, the link between what was and what will be. Astronomers study the space between galaxies not by what they can see, but by what they can infer. When light from distant quasars, brilliant beacons powered by black holes at the centers of faraway galaxies, travels across the universe, it passes through these intergalactic regions. Along the way, atoms of hydrogen absorb specific wavelengths of that light, leaving tiny fingerprints that can be detected by telescopes. These absorption lines tell us where gas lies between galaxies, how dense it is, and how it moves. Through this delicate work, scientists map the invisible, the unseen bridges that connect galaxies, the faint whispers of cosmic gas that once fed the formation of stars. It is one of the most delicate arts of observation, reading the silence of the universe itself. In that silence, there is motion. Even the vastness between galaxies is expanding. The universe itself stretches space, carrying galaxies farther apart as time flows forward. The farther a galaxy is, the faster it recedes, not because it moves through space, but because space itself grows. The regions between galaxies widen every moment, increasing the distance between everything. Billions of years from now, if the expansion continues, galaxies will drift so far apart that their light will no longer reach each other. Future observers, if any exist, may see only the stars of their own galaxy, surrounded by darkness, unaware of the larger universe that once was. The intergalactic space will become even more silent, more distant, a realm of pure stillness. Yet there is a strange peace in knowing this. The space between galaxies reminds us that the universe is not a chaotic storm, but a balance of presence and absence, of energy and stillness. It teaches us that even in apparent emptiness, there is order and depth. The dark, quiet expanses hold the memory of everything that ever was, the faint echoes of light, the subtle hum of creation, the timeless patience of the cosmos itself. To drift there, even in thought, is to feel time slow down, to feel the universe breathing in silence. The spaces between galaxies are not voids of meaning but sanctuaries of quiet. They are where the universe pauses between the bursts of starfire, where light journeys unbothered for billions of years, where gravity sculpts invisible patterns in the darkness. When we look at the night sky and see the galaxies shining like distant jewels, we are also looking at the darkness that holds them, the vast, unseen expanse that gives their light context and purpose. And perhaps, in that infinite quiet, we can find something deeply human, a reminder that even the emptiest spaces are part of something grand, something whole, something enduring. When we talk about the universe, our imagination gravitates toward the brilliant, We think of stars exploding into supernova, galaxies swirling in elegant spirals, and nebulae glowing in colors our eyes can barely perceive. Yet, all of these luminous structures combined make up only a tiny fraction of the cosmos. The rest, the vast majority, is something else entirely, an almost inconceivable expanse of what appears to be emptiness. Astronomers call these regions the cosmic voids, the spaces between galaxies, where matter thins out to its most delicate whisper. These voids are not just empty bubbles between clusters of galaxies. They are essential parts of the universe's architecture, shaping how matter moves, how galaxies form, and how cosmic evolution unfolds. The term void can be misleading. It implies a total absence, a place where nothing exists. But the cosmic voids are not truly empty. They are filled with traces of matter, thin streams of gas, lone particles of hydrogen, drifting ions, and above all, the subtle presence of invisible forces like dark matter and dark energy. These vast regions, which can stretch for hundreds of millions of light years, contain the faintest echoes of the Big Bang's energy and matter, diluted over eons of cosmic expansion. When scientists describe these spaces as having only a few atoms per cubic meter, that number feels impossibly small. But if you could somehow gather all the gas and dust in a single void and compress it, you'd still end up with an amount of matter equal to countless suns. Even in the universe's emptiest places, there is something, a thin thread of existence that never completely disappears. To visualize a cosmic void. Imagine a network of galaxies forming filaments across the universe. These filaments create vast, web-like structures, a cosmic lattice made of light and matter. Between these luminous strands lie the dark pockets of the voids, like great bubbles where few galaxies exist. Some of these voids are nearly spherical, while others stretch into irregular shapes defined by the gravitational dance of nearby clusters. The largest known voids can span more than 1 billion light-years across, dwarfing any single galaxy or even entire galaxy clusters. They are so immense that if you could travel at the speed of light, it would take you hundreds of millions of years just to cross one. Yet, their very emptiness has a profound role in shaping the cosmic web. The expansion of space pushes galaxies apart, and matter naturally flows away from these voids into denser regions, amplifying the contrast between what we see as filled and what we perceive as empty. Inside these voids, space feels timeless. If you could somehow exist there, in the absolute stillness between galaxies, you would see almost nothing. No stars nearby, no planets, no gas clouds bright enough to cast a shadow. The sky around you would be dark beyond imagination, dotted only by distant galaxies, so faint they appear as small points of light frozen in place. The silence would be deeper than any we can experience on Earth, because there would be no air, no medium to carry sound. Even temperature, the gentle vibration of particles, would drop to nearly absolute zero. In this place, motion slows, light weakens, and time itself feels stretched. A calm so complete it almost transcends understanding. Yet this calmness hides subtle activity. Within the voids, there are still particles, photons, and waves passing through. Cosmic rays stream endlessly from distant galaxies. Relic photons from the Big Bang travel unhindered, and dark matter's invisible gravity continues its quiet influence. Some voids even contain tiny dwarf galaxies, isolated systems of stars and gas that have drifted into solitude, disconnected from the cosmic crowd. These galaxies evolve differently from those in denser environments. Without nearby neighbors to collide or merge with, they age slowly, their stars burning with a steady patience. Scientists study them as cosmic time capsules, glimpses into what the early universe might have been like before gravity gathered matter into larger structures. Astronomers first began mapping these voids in the late 20th century. As technology advanced, surveys like the Sloan Digital Sky Survey and the 2-degree field galaxy redshift survey revealed something astonishing. The universe wasn't a random scattering of galaxies, but a grand structure, a web with dense clusters, connecting filaments, and vast empty spaces. These voids were not merely gaps, but enormous regions with unique dynamics. Gravity causes matter to flow out of them, so over billions of years, they become emptier. The process is like cosmic breathing. Galaxies migrate toward the filaments, leaving behind these expanding pockets of stillness. Scientists now know that the balance between these filled and empty regions determines how the universe grows and how dark energy drives its acceleration. Dark energy itself, the mysterious force pushing galaxies apart, acts most freely in the voids. With little matter to resist it, space expands more rapidly. There, in contrast, the denser regions where galaxies cluster experience slightly slower expansion due to gravity's pull. This uneven stretching creates the large-scale structure of the universe we see today. A delicate interplay between attraction and expansion, presence and absence. The cosmic voids are the quiet regions where dark energy's influence becomes most visible, shaping the rhythm of the cosmos. Despite their near emptiness, voids are not featureless. Modern observations using radio telescopes and high-energy observatories have revealed faint traces of intergalactic gas glowing in X-ray and ultraviolet wavelengths. This gas is incredibly diffuse, spread so thin that it can only be detected through its effect on the light of distant quasars. When quasar light passes through a void, some wavelengths are absorbed by atoms in the intergalactic medium, leaving delicate imprints called absorption lines. By studying these patterns, astronomers can map where matter lies, even when it's invisible to direct observation. Through these cosmic fingerprints, the silence of the void speaks. On a deeper level, cosmic voids offer insight into the nature of the universe itself. Because they are regions where gravity's influence is weakest, they preserve the early conditions of the cosmos better than dense areas. Studying them helps scientists understand the behavior of dark matter and test theories of cosmic inflation, the rapid expansion that occurred fractions of a second after the Big Bang. The voids, in their stillness, become laboratories of the universe's origin, allowing physicists to glimpse what space was like before galaxies existed. Some researchers even propose that the shape and distribution of voids could reveal clues about the fundamental geometry of spacetime, whether the universe is truly flat or slightly curved, and how it might evolve in the distant future. The beauty of these voids lies in their paradox. They are places of almost nothing, yet they define everything. Without them, galaxies would not cluster. Gravity would have no gradients to follow. The contrast between fullness and emptiness is what gives the universe its structure. In that sense, the cosmic voids are not the absence of creation, but its balance, the pauses between the bursts of light, the stillness that gives meaning to motion. Just as music depends on silence to shape its rhythm, the universe depends on emptiness to shape its form. To imagine standing inside one of these vast voids is to confront the true meaning of scale. If you could see the nearest galaxy, it might appear as a faint speck billions of light years away, barely distinguishable from a star. The background radiation from the Big Bang would bathe you in a dim glow of microwaves, the last trace of the universe's fiery birth. Time would feel endless because nothing around you would change quickly enough to mark its passage. The space between galaxies would stretch silently around you, like a cosmic sea without waves, its horizon unreachable. And in that stillness, you might begin to understand what the universe truly is. Not just the light that fills it, but the vastness that allows that light to shine. When we gaze at the night sky, we see stars scattered like glitter across a velvet backdrop, their faint light carrying across unimaginable distances. Yet, for all its brilliance, what we see is only a fraction of what exists. The universe that our eyes and telescopes can detect is merely the surface of something far greater, something unseen but undeniably present. Between the galaxies, within them, and surrounding them, there lies a hidden architecture, a web of invisible mass that gives structure to everything we know. This unseen component, which neither emits nor reflects light, is what scientists call dark matter. It makes up the silent skeleton of the cosmos, holding galaxies together and shaping the vast framework of the universe. It does not glow, it does not absorb, and it cannot be touched or seen directly, but its presence is felt everywhere. especially in the emptiness between galaxies, where its influence stretches unbroken across the dark. The discovery of dark matter began with curiosity and contradiction. In the early 20th century, astronomers studying the movement of galaxies noticed something strange. When they calculated how fast stars moved around the centers of their galaxies, they found that the stars were moving too quickly. If the only source of gravity was the visible matter, the stars, gas, and dust, then galaxies should have torn themselves apart long ago. There simply wasn't enough mass to hold them together. It was as if an invisible hand was tightening its grip, keeping the stars bound in their graceful spirals. That invisible hand, they realize, must be composed of something unseen, matter that does not emit light, but exerts gravity nonetheless. The same phenomenon was observed on larger scales, too. Clusters of galaxies moved as though they were embedded in massive halos of invisible material, suggesting that most of the mass in the universe is something we cannot see. Over the decades, evidence for dark matter has only grown stronger. Astronomers studying the bending of light around massive clusters, a phenomenon known as gravitational lensing, found that the amount of bending was far greater than the visible matter could produce. It was as if an invisible mass was warping space-time itself, magnifying and distorting the light of galaxies behind it. These cosmic lenses became natural observatories, revealing the hidden shape of the universe. Through them, scientists began to map the distribution of dark matter, tracing the contours of invisible structures that weave between galaxies like threads in an unseen web. In intergalactic space, far beyond the crowded realms of galaxies, dark matter dominates completely. The vast voids that seem empty to us are actually filled with its gravitational influence. Though we cannot see it, dark matter extends across these regions like a faint mist of gravity, connecting galaxies and clusters into a unified whole. Imagine the universe as a vast three-dimensional web. At the intersections of this web, galaxies form and shine, while the filaments that connect them, made mostly of dark matter, remain unseen. Without these filaments, the galaxies would drift apart, scattered by the universe's expansion. Dark matter is the glue of creation, invisible, yet indispensable. Despite decades of study, no one yet knows exactly what dark matter is made of. It does not interact with light or electromagnetic radiation in any known way. It passes through ordinary matter almost effortlessly. Scientists have proposed many candidates, from exotic particles that interact only through gravity to hypothetical objects formed in the earliest moments after the Big Bang. One of the leading theories suggests that dark matter could be composed of weakly interacting massive particles, or WIMPs, which would explain their gravitational effect without the need for electromagnetic interaction. Another theory suggests ultralight particles known as axions, so subtle that they ripple through the universe like waves, rather than discrete particles. There are also more radical ideas that dark matter might be tied to undiscovered dimensions, or that our understanding of gravity itself might be incomplete. What makes dark matter so mysterious is not just that we cannot see it, but that everything we do see depends on it. Every galaxy, every cluster, every large-scale structure in the cosmos owes its existence to the gravitational pull of dark matter. In the early universe, tiny fluctuations in the density of this invisible substance served as the seeds for all later formation. Ordinary matter, the kind made of atoms, was drawn toward these gravitational wells, gathering into stars and galaxies. The universe's luminous web grew within the scaffold that dark matter provided, its invisible framework guiding the formation of everything visible. If we could somehow remove all the dark matter from the universe, the galaxies would unravel, drifting apart into the void, their stars scattering like dust in the wind. In the space between galaxies, where ordinary matter is sparse, dark matter's dominance becomes even more apparent. Its gravity pulls faint streams of gas through intergalactic space, feeding galaxies and helping them grow. These invisible rivers of matter are what link galaxies into clusters and superclusters, giving the universe its large-scale structure. The filaments of dark matter can stretch for hundreds of millions of light years, connecting galaxy clusters like a cosmic nervous system. The light that travels through these filaments is subtly bent, revealing their presence through delicate distortions that only the most sensitive instruments can detect. These distortions form the faint fingerprints of dark matter, gentle ripples in the background of cosmic light that hint at the hidden reality beneath. Scientists have even simulated the universe using computers, inputting the laws of physics and watching as dark matter shapes a digital cosmos. The results are astonishingly similar to what we observe: networks of filaments and voids, galaxies forming at intersections, clusters glowing in the densest regions. Without including dark matter in these models, the universe we know could not exist. The simulations show that dark matter is not just a background element, it is the foundation of structure itself. It determines how galaxies rotate, how they cluster, and how the universe evolves. It is the unseen architect of everything luminous. The influence of dark matter extends into the smallest details and the largest scales. Even within our own Milky Way, it surrounds the galaxy in a vast halo, extending far beyond the stars. We live inside this invisible sphere, our solar system, swimming in a sea of dark matter particles that pass through us every second, unnoticed. On a cosmic scale, the same substance stretches between galaxies, binding them into patterns that resemble the neurons of a great cosmic brain. When astronomers map these structures, they are not just charting distances, they are tracing the gravitational fingerprint of something that pervades all space. The intergalactic darkness that seems so empty is, in truth, filled with this silent mass, shaping the flow of galaxies as surely as gravity holds us to Earth. There is something deeply poetic about dark matter. It reminds us that the universe hides its most powerful truths in silence. It tells us that visibility is not the same as importance, that what we cannot see can still be the force that holds everything together. For all the luminous beauty of galaxies, it is the invisible darkness between them that gives them form. This invisible substance, silent and cold, moves through the cosmos like a ghostly tide. It does not shine, but it binds the shining things. It does not speak, but it defines the structure of the universe. When we look into intergalactic space and imagine it empty, we are in fact looking at the unseen depths of creation. There, between galaxies, dark matter continues its eternal work, holding, connecting, shaping, never resting, never revealing its true face. It is the universe's greatest mystery and its most faithful constant, the hidden mass that gives meaning to the light between the galaxies. In the vast distances that stretch across millions of light years, there exists a substance so rarefied and delicate that for much of human history it was believed not to exist at all. The regions between galaxies were once thought to be true voids, empty, silent expanses of pure nothingness. But as our instruments grew more sensitive and our observations more precise, scientists discovered that these spaces are not entirely empty. They are filled with the faintest traces of gas and plasma, a thin intergalactic medium that permeates the universe like an invisible mist. This is the cosmic breath between galaxies, ancient, diffuse, and nearly imperceptible, yet it plays a crucial role in the life and evolution of everything in the cosmos. The intergalactic medium, or IgM, is composed mostly of hydrogen and helium, the simplest and oldest elements born in the fiery first minutes after the Big Bang. When the universe was young, it was hot and dense, filled with plasma, a state of matter where atoms are stripped of their electrons. As the universe expanded and cooled, protons and electrons combined to form neutral atoms, and light was finally able to travel freely. But gravity began to gather matter into clumps, forming galaxies and clusters. The gas that didn't collapse into these structures remained behind, stretched thin across the enormous spaces in between. It is this gas, ionized by cosmic radiation and heated by violent events in the universe, that makes up the intergalactic medium we know today. Although the IgM is incredibly tenuous, its sheer scale makes it one of the universe's most significant components. If you were to take a cube of space 1 meter across from an intergalactic void, you might find only a few atoms in it, far less than even the emptiest vacuum we can create on Earth. Yet when you consider that these atoms fill billions of cubic light years of space, Their total mass adds up to an enormous fraction of the universe's baryonic matter, that is, the ordinary matter made of protons and neutrons. In fact, scientists believe that most of the universe's ordinary matter exists not within galaxies, but in the intergalactic medium, floating quietly between the clusters of stars. This faint gas is invisible to our eyes, but it reveals itself through its interactions with light. When light from distant quasars, brilliant beacons powered by supermassive black holes, travels across the universe, it passes through clouds of intergalactic gas. Each time it encounters hydrogen, a specific wavelength of light is absorbed, leaving behind a series of dark lines in the quasar spectrum. This pattern, known as the Lyman alpha forest, acts as a kind of cosmic barcode, encoding information about where and how much gas lies between us and the quasar. By studying these spectral fingerprints, astronomers can map the distribution of gas across vast stretches of space and time. In doing so, they uncover the hidden structure of the universe, the filaments and voids that form the cosmic web. The intergalactic medium is not uniform. It exists in various states, depending on temperature and density. Some regions are cooler and denser, containing neutral hydrogen that absorbs ultraviolet light, while others are hotter and more ionized, glowing faintly in X-rays. These hotter regions are often found near galaxy clusters, where powerful gravitational forces heat the gas to millions of degrees. As galaxies form and evolve, they interact with this gas, pulling it inward or expelling it outward through powerful winds driven by supernova explosions or black hole activity. This constant exchange between galaxies and the intergalactic medium is what scientists call the cosmic feedback cycle, a process that regulates star formation, galaxy growth, and the overall evolution of the cosmos. When a galaxy forms stars, it draws in gas from its surroundings, converting it into luminous energy and heavier elements. But the explosions of dying stars send shock waves back into space, heating the surrounding gas and sometimes pushing it out into intergalactic space. The faint gas that drifts between galaxies is the silent witness of this cosmic recycling, carrying the chemical fingerprints of generations of stars. If we could see the intergalactic medium with our eyes, it would look like a vast network of soft, glowing threads connecting galaxies. These filaments are faint beyond comprehension, their light stretched and dimmed by cosmic expansion. Only the most powerful telescopes, like the Chandra X-ray Observatory or the Hubble Space Telescope, can catch glimpses of this diffuse structure. Recent advances in observation have revealed faint ultraviolet and X-ray emissions coming from the intergalactic gas, confirming that it glows softly with the heat of ancient cosmic events. Every photon that escapes from it tells a story of galaxies colliding, of stars dying, of black holes feeding and releasing energy back into space. The intergalactic medium is also the stage upon which some of the universe's most dramatic events play out. When galaxies collide, their gravitational forces stir the surrounding gas, creating shock waves that travel for millions of light years. When supermassive black holes release jets of energy, those jets carve cavities in the intergalactic medium, sculpting its shape. The IGM is not passive, it responds to these colossal events, carrying the echoes of cosmic history across the ages. It is a record of the universe's most powerful processes, a diffuse library of light and heat written across the darkness. Even within the so-called voids of the cosmic web, the enormous empty spaces between filaments, there is still some intergalactic gas, though it is spread incredibly thin. These regions are the universe's quiet zones, where gravity has pulled most matter away, leaving behind only the faintest residue. Yet even there, the gas is influenced by the overall expansion of space, stretching and cooling as the universe ages. It may seem static, but it is in constant, gentle motion, slowly changing as cosmic time flows on. Scientists studying the IGM are not only learning about the space between galaxies, they are uncovering clues about the universe's evolution. The temperature, composition, and density of this gas tell us how the first galaxies formed, how they interacted with their environment, and how the universe transitioned from its early opaque state to the transparent one we see today. The intergalactic medium is like a fossil record of cosmic history, holding the imprints of events that shaped the galaxies we now observe. As our instruments improve, astronomers are beginning to detect even more elusive forms of intergalactic matter. One of the most intriguing discoveries of recent years is the existence of the warm-hot intergalactic medium, or WIM, a phase of gas with temperatures between 100,000 and 10 million degrees. This gas is so diffuse that it emits only faint X-rays, but it may contain a large fraction of the universe's missing baryons, the ordinary matter that theories predict should exist but has been difficult to observe. The WIM acts as a bridge between galaxies, filling the filaments of the cosmic web and serving as the hidden connective tissue of the cosmos. This intergalactic plasma, heated by shocks and cosmic radiation, may also carry magnetic fields that thread through space. These fields are weak, but they could play a role in shaping the flow of gas, influencing how galaxies acquire matter, and perhaps even guiding the propagation of cosmic rays. Although these magnetic fields are faint, they hint at a universe that is not static, but subtly alive, a cosmos where even the emptiest regions hum with unseen energy. If you could somehow travel into this faint gas, you would not notice it with your senses. The particles are so widely spaced that you could move through them, as though they were not there at all. Yet, in their stillness, they are the background rhythm of the cosmos. Every particle drifts in the slow expansion of space, every atom a remnant of creation. Together, they form the thin connective tissue between galaxies, the medium through which light travels, the bridge that unites all cosmic structures. The intergalactic gas and plasma remind us that the universe is never truly empty. Even in the dark, cold reaches between galaxies, matter persists in its most delicate form, shaped by gravity, warmed by ancient energy, and illuminated by the faintest glow. It is the quiet substance of the universe's breath, a soft whisper of creation lingering in the silence between stars when we look up at the night sky. It seems as if the stars are scattered randomly across a dark backdrop, each glowing quietly in its own isolated patch of space. But if we could step back far enough, unimaginably far, beyond any galaxy, beyond the clusters and superclusters, and see the universe on its grandest scale, a breathtaking structure would come into view. The universe is not random at all. It is woven together like a vast, luminous tapestry of threads and knots, an intricate network of matter and energy stretching across the cosmic horizon. This immense structure is what astronomers call the cosmic web, a three-dimensional web of filaments, clusters, and voids that binds the entire universe together. It is within this web that galaxies are born, where they live out their lives, and where they remain tethered by invisible gravitational threads that span the cosmos. The cosmic web is perhaps the universe's most majestic design, delicate, complex, and immense beyond measure. Its filaments are composed mostly of dark matter, intertwined with ordinary matter in the form of gas, plasma, and galaxies. These filaments act like cosmic highways, channeling matter through the vastness of space, guiding it toward the densest regions where clusters of galaxies form. Between these filaments lie the cosmic voids, enormous, empty regions that seem almost devoid of matter. The contrast between the luminous strands and the deep voids defines the shape of the universe itself. Like veins in a leaf or neural pathways in a brain, the cosmic web is both functional and beautiful, a structure that connects everything from the smallest galaxy to the largest supercluster. This grand pattern began billions of years ago. In earliest moments after the Big Bang, the universe then was almost uniform, filled with hot plasma that glowed with the perfect balance of matter and radiation. But within that smoothness, there were tiny fluctuations, slight differences in density, perhaps 1 part in 100,000. These small variations, magnified by gravity over time, became the seeds of all future structure. Denser regions pulled in more matter, growing heavier and stronger, while emptier regions became voids. Over billions of years, this gentle tug of war between gravity and cosmic expansion sculpted the vast architecture we now call the cosmic web. The filaments of the web are where galaxies are born, Within them, dark matter provides the gravitational scaffolding, drawing in ordinary gas that cools, condenses, and ignites into stars. The densest intersections of these filaments, where multiple strands meet, form massive galaxy clusters, the cosmic cities of the universe. In contrast, the long filaments between clusters act as cosmic highways, connecting one region to another and allowing matter to flow over billions of years. Through these pathways, galaxies are not isolated entities, but participants in a grand interconnected system, shaped by the same invisible forces that stretch from one end of the cosmos to the other. To visualize this, imagine a vast three-dimensional spider web made of light. Each strand represents a filament of dark matter and gas, and along those strands lie the galaxies, tiny glowing beads on an enormous string. Between the strands are immense voids, where the density of matter drops to almost nothing. This is not a metaphor, but a reality supported by observation. Astronomers using powerful telescopes and computer simulations have mapped this web across billions of light years, revealing a universe more interconnected than anyone once imagined. These maps, built from surveys of millions of galaxies, show that the universe's structure resembles a living network, with filaments stretching across hundreds of millions of light years, intersecting at nodes where clusters of galaxies shine the brightest dot in these filaments. The flow of matter is constant, but slow, unimaginably slow from our perspective, yet steady across cosmic time. Galaxies drift along the gravitational channels carved by dark matter, pulled by the collective mass of the web. Over billions of years, some merge to form larger systems, while others move outward into quieter regions. This motion is part of the cosmic dance that continues even now. The web is not static. It is evolving. As the universe expands, the filaments stretch, the clusters grow denser, and the voids become emptier. In this slow, majestic motion, the universe maintains its balance, preserving the pattern that has endured for more than 13 billion years. The cosmic web is not made visible by ordinary light, but astronomers can trace it through the faint signatures it leaves behind. When light from distant quasars passes through intergalactic gas along these filaments, some of it is absorbed at specific wavelengths, creating patterns in the light spectrum. These absorption lines act like signposts, marking where the gas lies and revealing the shape of the web. More recently, scientists have used gravitational lensing, the bending of light by massive structures, to detect the presence of dark matter within these filaments. By measuring how the light of background galaxies is subtly distorted, researchers can map the invisible mass that weaves through the cosmos. In these delicate distortions, the shape of the web emerges like a ghostly outline, confirming that the universe's structure is far from random. Even more astonishing is how this web seems to mirror patterns found in other realms of nature. The branching filaments resemble neural networks in the brain, the distribution of lightning through clouds, or the flow of rivers across a landscape. Each system, governed by its own laws, tends toward efficiency paths that minimize energy and maximize connection. The cosmic web, too, follows a similar principle, shaped by gravity's relentless pull toward balance. Some scientists and philosophers have even drawn poetic comparisons between the cosmic web and the architecture of consciousness itself, suggesting that the universe may organize information in ways that echo our own biological systems. Whether or not these parallels carry deeper meaning, they remind us that structure and order are woven into the fabric of existence at every scale. At the intersections of the web, where filaments meet, lie the largest known structures in the universe, the superclusters of galaxies. These colossal formations contain thousands of galaxies bound together by gravity, each one a vast city of stars. The Virgo supercluster, of which our Milky Way is a part, is one such node in the cosmic web. Beyond it lies an even greater region known as Laniakea, our home supercluster, stretching over 500 million light years. These immense structures are like cosmic capitals, connected by invisible highways of matter, their gravity influencing the motion of galaxies millions of light years away. The Milky Way, our quiet spiral of stars, moves through this web as part of a larger flow. drawn along invisible currents toward regions of greater density, toward the gravitational center of our cosmic neighborhood. But even as these colossal structures grow and evolve, the spaces between them expand. The universe continues to stretch, driven by dark energy, causing the filaments to thin and the galaxies to drift farther apart. In the distant future, the cosmic web may become fainter, its luminous threads dimming as galaxies move beyond one another's reach. Yet for now, it stands as a testament to the universe's interconnected nature, a structure of order born from chaos, of complexity rising from simplicity. Computer simulations have allowed scientists to witness this process unfold. Starting from the early universe, they model how dark matter and gas interact over billions of years. In these simulations, the cosmic web grows like a living organism, filaments branching and merging, clusters forming at the crossroads. The resemblance to living systems is striking, though the web is not alive in any biological sense. It is the product of fundamental forces: gravity, expansion, and motion working in harmony. The beauty of the cosmic web lies not only in its structure, but in the way it embodies the balance of opposites: emptiness and fullness, light and darkness, chaos and order. In the vastness of intergalactic space, the cosmic web is the silent architecture that connects everything. It is the unseen lattice upon which the galaxies rest, the framework that allows stars to form and light to travel. It stretches across the observable universe, binding matter in patterns too large for the human mind to fully grasp. And though it is invisible to our eyes, its presence can be felt in every direction. In the pull of gravity that shapes galaxies, in the faint glow of distant gas, in the subtle distortions of light that whisper of hidden mass. The cosmic web is the universe's grand design, a network of connections so immense and delicate that even the spaces between galaxies are part of its infinite thread. Across the vast and silent stretches between galaxies, there exists a traveler that never stops moving. It does not tire, it does not decay, and it has journeyed longer than any other thing in existence. That traveler is light. From the moment it is born, whether in the heart of a star, in the afterglow of the Big Bang, or in the violent release of a supernova, it begins its endless voyage through the universe, crossing billions of light years, weaving its way through the cosmic web, and brushing past invisible rivers of dark matter. Even as galaxies drift apart, light continues, slipping silently between them, carrying with it the memory of everything that has ever been illuminated. The space between galaxies might appear dark, but it is not empty of light. It is filled with a faint, ancient glow, a delicate veil of radiation that has been traveling since the dawn of time. The oldest and most pervasive of these travelers is the cosmic microwave background radiation, or CMB, the afterglow of the Big Bang. Born when the universe was just 380,000 years old, it is the remnant of a time when matter and light were first able to part ways. Before that, the universe was a blinding fog of plasma, so dense and hot that photons could not move freely. But as the universe expanded and cooled, atoms formed, and light was finally able to travel unobstructed for the first time. That light has been journeying ever since, stretched and softened by the expansion of space, until it now whispers across the cosmos as microwaves, a faint background hum that fills all of existence. If we could see the universe not in visible light, but in microwaves, we would see that this radiation is everywhere, uniform and unending, a soft blanket covering all of creation. When astronomers first detected it in 1965, it was a revelation. The cosmic microwave background was the first direct evidence that the universe had a beginning, a warm and brilliant origin that left behind this glowing signature. Even though its temperature is only about 2.7 degrees above absolute zero, it carries profound meaning. Each tiny fluctuation in its temperature, 1 part in 100,000, represents the seeds of structure, the faint fingerprints of matter that would later grow into galaxies, stars, and planets. It is the oldest light we can see, the first memory of the cosmos, still traveling unbroken through the silent spaces between galaxies, But the CMB is only one kind of ancient light that lingers in intergalactic space. There are others fainter, younger, and more varied. Some come from the first stars, the earliest bursts of starlight that illuminated the universe after its long dark ages. Others come from quasars, the brilliant cores of young galaxies powered by supermassive black holes. Their light races outward, crossing unimaginable distances, dimming and reddening as it passes through the expanding universe. Many of these photons will never strike another object. They will travel forever, slipping endlessly through intergalactic darkness, a perpetual testament to the energy that once burned within galaxies long vanished. Cosmic rays are another form of travelers between galaxies. Though they are not light, but particles, protons, nuclei, and electrons accelerated to near the speed of light by supernova explosions or the magnetic fields of distant galaxies. These particles move across the intergalactic voids like messengers of high energy, colliding with stray atoms of gas, creating faint glows of X-rays and gamma rays that reveal the invisible presence of the intergalactic medium. Even in the emptiest parts of the universe, this faint radiation is there, a subtle, eternal reminder that the cosmos never truly sleeps. In intergalactic space, light behaves differently than we experience it on Earth. There are no clouds, no dust, no atmosphere to scatter or absorb it. A single photon, once released, can travel for billions of years without interruption. Over time, as the universe expands, the space that light moves through stretches, and the wavelength of that light stretches too. Blue light becomes red light becomes infrared, and energy fades into the cold hum of the microwave background. This process, known as redshift, is a cosmic record of distance and time. By measuring how much light has stretched, astronomers can tell how far it has traveled and how long it has been on its journey. Every faint beam of light between galaxies is, in a sense, a time machine, a message from the past, carrying within it the story of when and where it began. There is another, even more delicate form of light filling the space between galaxies, the cosmic infrared background. It is made up of the combined glow of countless stars and galaxies, too faint or distant to see individually. It is a sea of ancient starlight, scattered and reprocessed by cosmic dust, radiating softly in the infrared spectrum. Like the cosmic microwave background, it surrounds everything, invisible to the naked eye but measurable by sensitive instruments aboard space telescopes. This diffuse radiation is a record of the history of star formation itself, a quiet echo of all the stars that have ever burned across cosmic time. Even in its silence, intergalactic space glows faintly. The ultraviolet and X-ray radiation emitted by quasars and young galaxies permeates the intergalactic medium, keeping its rarefied gas ionized and warm. Though that gas is extraordinarily thin, just a few atoms per cubic meter, it is enough to interact with light passing through it. Astronomers detect these interactions as absorption lines in the spectra of distant quasars, tiny notches in the light that reveal the invisible presence of intergalactic clouds. In this way, light not only illuminates space, but also tells the story of what lies hidden within it. It is humbling to think that the light now reaching our eyes from distant galaxies began its journey long before Earth even existed. When a photon from galaxy 10 billion light-years away finally arrives, it has traveled through a universe that has changed completely since it was born. Galaxies have formed and merged, stars have lived and died, and entire cosmic structures have grown from tiny ripples in the early universe. Yet that single photon has continued unbothered, a survivor of time and expansion, finally meeting the mirror of a telescope on a small blue planet orbiting an ordinary star. In that moment, something ancient and vast becomes known. Astronomers often say that to look at the night sky is to look into the past, and nowhere is that truer than in the light that passes between galaxies. Each glimmer that reaches us is a message from another era, sometimes from the dawn of creation itself. The photons of the cosmic microwave background began their journey nearly 14 billion years ago. Those from the first stars began traveling more than 13 billion years ago. The light from the farthest galaxies we can detect today started its voyage when the universe was less than 1 billion years old. Between galaxies, that light drifts freely, carrying the record of every age, a continuous archive written in the language of energy. But not all light travels forever unimpeded. Some of it is absorbed or scattered by the thin gas of the intergalactic medium. When this happens, it does not vanish, it transforms. Absorbed photons transfer their energy to electrons, heating the gas or changing its ionization state. Eventually, that energy is re-emitted as new photons of different wavelengths. In this way, light participates in a constant exchange, a slow cosmic conversation between radiation and matter. Nothing is lost, only altered, reshaped, and set forth again to travel across the void. Beyond light itself, there is another kind of radiation that fills the space between galaxies, gravitational waves. These are ripples in spacetime, generated by cataclysmic events such as colliding black holes or neutron stars. Though they are not light in the traditional sense, they too carry information across the universe, traveling at the speed of light, undisturbed by matter. They pass through galaxies and voids alike, bending and stretching spacetime itself as they go. In the stillness between galaxies, these waves move endlessly, carrying the silent rhythm of cosmic events from one end of the universe to the other. All of this radiation, light, particles, and waves forms a kind of invisible ocean that fills intergalactic space. It is diffuse, faint, and cold, but it is there, whispering the history of the cosmos. Each photon, each particle is a relic of something once burning brightly, once alive with energy. Together, they create a background of light that never ends, a cosmic hum that resonates through the infinite night. And so, between galaxies, there is more than emptiness. There is memory, there is movement, there is the eternal journey of light, crossing distances beyond imagination, carrying with it the echo of creation, the music of stars, and the faint trace of everything that has ever existed in the immense expanse between galaxies. Where light fades into the deep black of space, there exists a delicate balance that defines the nature of the universe itself. To the human eye, these regions seem like endless voids, places where nothing exists, where silence reigns unbroken. Yet what we call darkness is not the absence of reality, but the stage upon which all energy moves. Between the beams of ancient starlight and the shadows of the cosmic void, an invisible balance of forces continues to shape the cosmos, an equilibrium between light and darkness, matter and emptiness, gravity and expansion, that has endured since the beginning of time. The story of this balance began in the first moments after the Big Bang, when energy and matter were one and the same, entwined in a dance of creation. In those first fractions of a second, the universe was neither dark nor light, but a dense, radiant sea of pure energy. As it expanded and cooled, matter began to form protons, neutrons, and electrons, and soon, the first atoms. This transition marked the beginning of structure, the start of the long relationship between matter and radiation. The early universe glowed with brightness, yet within that brightness lay the seeds of shadow. Where there was more matter, gravity began to gather it together, and where there was less, empty regions began to emerge. In this way, light and darkness became partners in the shaping of the universe, one revealing, the other concealing, yet both essential to balance. Today, billions of years later, this cosmic equilibrium continues to govern everything that exists. The light that fills the cosmos from stars, galaxies, and the faint radiation of the Big Bang makes up only a tiny fraction of the total energy of the universe. The rest lies hidden, unseen, and mysterious. About 27% of the universe is composed of dark matter, the invisible mass that holds galaxies together. Even more elusive is dark energy, which makes up roughly 68% of the cosmos and drives its accelerating expansion. Ordinary matter, the kind that forms stars, planets, and people, accounts for less than 5% of everything. The universe, then, is not built primarily from light or substance, but from the Unknown, the unseen energy that fills the space between galaxies and shapes the fate of everything that exists. Dark energy is perhaps the most profound mystery of all. It is not a substance that we can see or touch, nor a force that behaves like gravity or magnetism. It is the property of space itself, a pressure, a tension, an invisible essence that pushes the universe apart. Discovered through the observation of distant supernova in the late 1990s, dark energy revealed that the expansion of the universe is not slowing down, as once thought, but speeding up. This discovery changed our understanding of the cosmos entirely. The emptiness between galaxies, once believed to be passive, turned out to be active, dynamic, alive with energy. The void was not void at all, it was the dominant player in the cosmic drama. In intergalactic space, this dark energy exerts its quiet influence everywhere. Galaxies drift apart faster and faster, carried on the flow of an expanding spacetime. The filaments of the cosmic web stretch thinner, and the great voids grow ever wider. Over immense timescales, dark energy will determine the destiny of the universe itself. If its influence continues to increase, it will one day pull galaxies so far apart that even the nearest ones will vanish beyond visibility. The night sky, as seen from any star system, will grow empty, and light will have to travel greater and greater distances before encountering another source. Yet within that emptiness, dark energy will still remain, filling space with the quiet, unending presence. Between light and darkness, there is also another kind of balance, a quantum balance. At the smallest scales of existence, where particles and energy fluctuate endlessly, the vacuum of space is not truly empty. Even in the deepest intergalactic void, virtual particles appear and disappear in the blink of an eye, borrowing energy from the quantum field and returning it just as quickly. This constant flickering of existence, known as quantum vacuum energy, fills all of space with a faint hum of activity. The balance between the energy of these quantum fluctuations and the expansion of the universe is one of the great puzzles of modern physics. It is as though the void itself breathes, expanding and contracting on scales so small and fast that we cannot yet fully perceive it. This interplay between darkness and energy extends beyond science into the poetic fabric of understanding. Light, in its essence, represents what can be seen, measured, and known. Darkness represents what lies beyond the limits of perception, the hidden, the infinite, the potential. The universe, balanced between these two, is an endless negotiation between clarity and mystery. Even in the most illuminated regions, like the heart of a galaxy, there is darkness between the stars. And even in the darkest reaches of intergalactic space, there is light, faint, ancient, enduring. This coexistence defines the cosmos not as a place of opposites, but as a spectrum where energy takes many forms, all bound by the same cosmic law of balance. In a very real sense, the space between galaxies is where this balance is most evident. There, gravity, light, and dark energy engage in a subtle contest. Gravity pulls matter together, forming galaxies and clusters, while dark energy drives them apart. The result is a cosmic stalemate, a universe that neither collapses into itself nor expands into emptiness too quickly. The balance between these forces allows structure to exist. It allows galaxies to form, stars to shine, and life to emerge. Without dark energy, gravity would eventually pull everything together. Without gravity, dark energy would scatter everything into a thin mist of radiation. Together, they create the tension that holds the universe in motion. Every photon of light that passes through intergalactic space is a witness to this balance. As it travels, it stretches with the expanding universe, losing energy but never disappearing. Each photon becomes longer in wavelength, shifting from visible light to infrared, then to microwave, and eventually to radio waves. In the distant future, when galaxies have drifted beyond one another's reach, all light will be stretched into darkness, fading into the low hum of background radiation. Yet even then, that faint hum will persist. Energy, according to the laws of physics, can never be destroyed, only transformed. Light will not die. It will change form, continuing its silent journey across space and time. This transformation mirrors the universe itself. The cosmos began in a blaze of light, and over billions of years, that light has thinned and softened, giving way to shadow. Yet in the darkness, energy continues to flow. Stars burn and fade, galaxies collide and merge, and through it all, the balance remains. The energy that once burned as light now exists as heat, motion, and potential. Even the particles of dark matter and the fields of dark energy participate in this great exchange. Nothing is lost, only redistributed, rebalanced, and renewed across cosmic scales. As we come to the end of this quiet journey through the cosmic darkness, we begin to sense that the space between galaxies is not an absence, but a profound presence, a vast, silent sea that holds together the luminous islands of creation. What lies between galaxies is not nothingness, but the unseen fabric of the cosmos itself, a delicate balance of energy, matter, and mystery. It is the stage upon which the drama of the universe unfolds, the background that gives meaning to every shining star and swirling galaxy. In this infinite silence, we glimpse the deep structure of reality, the filaments of dark matter that weave galaxies into clusters, the faint glow of intergalactic gas whispering across light years, the quiet hum of ancient radiation that has journeyed from the dawn of time. These are the remnants and reminders of a cosmic story billions of years in the making, a story still unfolding in every corner of the night sky. But beyond the science, beyond the mathematics of expansion and the measurements of mass, lies something deeper, something felt rather than calculated. Between galaxies stretches the very idea of infinity, a reminder of how small we are, yet how far our curiosity has carried us. From a single planet circling an ordinary star, we have learned to look across billions of light years and imagine the unseen, to listen for echoes of creation in the silence of space, and to find beauty not just in the light, but in the darkness that surrounds it. The universe between galaxies is both the greatest mystery and the greatest truth we can know, a vastness that humbles and uplifts us at once. It teaches us that the universe is not simply filled with things. It is filled with connections, with the quiet threads of energy and time that bind everything together. And in that awareness, we begin to understand that we too are part of that cosmic web, not separate from it, but born of it, sustained by it, and destined to return to it. As we drift toward sleep, let the thought settle gently within you. Between galaxies, there is silence, but it is not empty. It is the universe, breathing softly, patiently, eternally. It is the space where all beginnings rest and all possibilities unfold. In that silence, we find peace, the peace of knowing that we belong to something vast, timeless, and endlessly beautiful, something that stretches far beyond the reach of stars, yet resides quietly within every heartbeat of existence.